Hello, and today's purpose of the day is I can rewrite linear equations in 3 different forms and determine what makes two lines parallel or perpendicular. Parallel and perpendicular lines. What do we know about lines that are parallel? Well, we know that they never intersect or cross. We also know that they have the same slope, so the value in front of x will be the same. And parallel lines are straight and go on forever, so that's a little bit of a given. So the two major things I would say would be that they never intersect, that they have the same slope. So now steps to write an equation that goes through a particular point and is parallel to the line. Has a couple different steps. One, we are going to, and we'll go through an example, but to put the steps in words, one, we'll plug in the given point. And use the slope that is given in the equation because parallel lines have the same slope. And we'll replace the y-intercept with the variable. And that variable we'll call b. Then we'll solve for b. And then rewrite the equation with the new b, which is the y-intercept, and the slope. So those are the steps. Hopefully you're starting to recall that. And let's take a look at an example. So here with this example, I have a point and a line. I want to write an equation that's parallel to this equation that goes through this particular point right there. So what I'm going to do is I'm going to plug in the given point, so x and y. So I'll say -3 equals my slope times my x-coordinate plus b, and then I'll solve for b. And I don't necessarily care about the 4. I'm going to throw it out. I don't need it for this example. And -2/3 times 2 is -4/3. So when I add 4/3 to both sides, -3 plus 4/3, I'm going to squeeze my work in here. -3 plus 4/3 is -1 2/3. So -1 2/3 equals b, or I could call that -5/3. So then to rewrite my equation for that parallel line, I would have y equals -2/3 x minus 1 2/3. So similar to writing an equation, that passes through a particular point and has a certain slope. This is very similar to those steps for a line that's parallel. Now when we get to perpendicular, that's a little bit different. There's just one extra step that we have to make. So let's recall what's important about perpendicular lines. Well, they form 90-degree angles. Or right angles, I should say. And what's unique about their slope is they have opposite reciprocal slopes. And the lines intersect once, we could say. So the big important idea is that opposite reciprocal slope, because that's going to help us when we actually have to write an equation of a line that goes through a particular point and is perpendicular to another line. So with those steps, we'll do similar things to the last steps in the parallel lines. We'll plug in the given point, but then we'll change the slope to its opposite reciprocal right away. And then replace y-intercept with b, with that variable. And this looks like x, but that should be y. Then we'll solve for b. And then just like the last couple steps, we'll rewrite with the new y-intercept and opposite reciprocal slope. So let's take a look at an example. I have my x and y coordinate, my point, and I see my slope is -3. So the opposite reciprocal of -3, this is really like -3/1. I'm going to flip the fraction and change the sign. So if it was positive to or negative to begin with, it's positive at the end. If it's positive to begin with, then it's negative for the opposite reciprocal. So I'm going to plug in 1/3 for my slope. Okay, so m equals 1/3. And so I'll have here -2 equals m times x plus b. 1/3 of 6 is 2. And I'll subtract 2 and solve for b. So b equals -4, so my final answer is y equals, with my new slope, my opposite reciprocal, 1/3 x minus 4. Now let's look at how would you determine if two lines are parallel, perpendicular, or neither. So when we're given equations, we want to find out what their slopes are. So what would be most helpful is if we rewrote these into slope-intercept form, which is what we're also going to practice for today's some of today's learning targets. So if I rewrite both of these equations to slope-intercept form so that I can actually see what their slope is, I can then compare. And if they're the same slope, the lines are parallel. If they're opposite reciprocal slopes, they are perpendicular. And if they don't relate at all, we'll say that they're neither related with being parallel or perpendicular. So let's rewrite this first equation into slope-intercept form. I want to get y by itself, so I'll subtract 3x. And then I'll divide by 5. So I get y equals -3/5 x plus 2. Now for my other equation, I have 5x minus 3y equals -6. I'll subtract 5x and then divide by -3. So if I look at comparing the two slopes, -3/5 versus 5/3, those are opposite reciprocal slopes, so we can conclude that these lines are perpendicular. So again, we want to figure out the slopes with both of those equations. Okay, now let's move on and let's look at the three different forms of linear equations. Standard form. Standard form is ax plus by equals c. A couple rules on standard form is that the a term must be positive. So that coefficient must be positive. We also cannot have any fractions or decimals in standard form. So a couple of rules, and we'll look at a few examples of that in class. Slope-intercept form is y equals mx plus b. There are no major rules with that. The only thing I would recommend is to make sure when you have your slope is written as a fraction, not as a decimal. And point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. And this is where we'll plug in points for y1 and x1, and our slope, typically those will be filled with numbers and won't be variables. So one more addition to point slope form that we can talk about is from point slope form, it's really easy to identify the point and slope from the following equations. The only thing that I want to stress and remind you is that we need to remember that we need opposite signs for the point, because the equation is, like written above, y minus y1 equals m times the quantity x minus x1. So the equation actually starts with subtraction signs, right? Or that's what's in the formula. So we need to take that into account. So when we are looking here at taking out the point and the slope is really easy. It's the number in front of the parentheses. But here for your point, we have 3 and then -3. But in order for that, so y plus 3, in order for that to be a plus 3, there must have been placed in a negative 3 in order to actually turn to a plus sign, which is what is written here. So really the point that's the opposite coordinate, or the opposite sign for that ordered pair in the coordinate, and then the x minus 3, there must have been put in a positive 3 for that negative sign to stay there. So here the ordered pair is 3, negative 3. Okay, in the second example, your slope is 3, and your point, remember, look at the opposite signs, would be negative 4, comma 5. So again, that's just one thing to remember, that you need the opposite signs for the point that you take out in point-slope form. Thanks for listening. Have a great day. Bye-bye.